hope you guys are enjoying this. These are some well-presented, well-put-together presentations, setting the bar high. Next up is Amy Oldham. We do Amy's bio. Amy Oldham is the daughter of Larry and Dawn Oldham and was born in Orlando, Florida. She's attended the First Academy for 6 years. She's been actively involved in music by leading worship at both her school and her church. She plays guitar, piano, sings, writes music, and has her own YouTube channel. Amy has also been very involved in athletics. She's played volleyball ever since she began attending First Academy, earning 2 state championship rings and being the captain of her club team. Amy plans to attend the University of Central Florida, and her major is currently undecided. No matter what major she ends up choosing, she is excited to see how God will use her in the future.
Yeah!
Hi, my thesis is on the science of music and how it can be used to support the theory of intelligent design. But before we understand music, you have to understand the concept of sound. All sound starts with a vibration. When you pluck a guitar string, the string moves back and forth, also moving the air particles around it back and forth. As these particles continue to compress and refract, it causes a sound wave. Physically, this is what the particles are doing as they travel to your ear, and graphically, this is how we represent it. Frequency is the number of wave cycles per second, and as frequency increases, pitch also increases. Therefore, little kids typically have a higher frequency of a voice, and men have a lower frequency of a voice. The amplitude of a wave is the height of it, and this indicates the volume. The next step in the sound process is when those vibrations hit your ear. Your ear is made up into 3 sections. The first section is the outer ear, which consists of the pinna, the auditory canal, and the eardrum. The middle ear consists of the ossicular chain, which is the 3 smallest bones in the human body. The inner ear is where it gets really complicated because that consists of the oval window and the cochlea. The cochlea consists of 30,000 hair-like sensor cells, which are each divided up into sections. Each section is responsible for recognizing a certain frequency. Therefore, that's how your brain recognizes what pitch that you're hearing. Now we face the question, what's the difference between mere noise and music? The answer lies simply within the waveforms. A musical note, the waveforms are consistently patterned. But if I were to drop a pile of glass plates, you'd be hearing mere noise, which are random and sporadic waveforms. Now when I play this note on this keyboard, what you're hearing is the blue wave, but you may be surprised to learn that actually other frequencies are going on behind that. Even the green wave and the red wave and many other waves that aren't pictured on the graph are going on at the same exact time. The reason you only hear the blue wave, which is that one note I just played on the keyboard, is because that is the dominating frequency referred to as the fundamental frequency, and it's the lowest, so it dominates all the others. Those additional frequencies going on behind the fundamental frequency are called overtones. These overtones are what cause distinctions in instruments and voices. So the reason a guitar sounds different from a piano, and the reason my voice sounds different from Mr. Kavanaugh's voice, is because the combinations and the overtones of our voices are different. Now when it comes to harmony and consonance, when 2 notes can be compared in a simple ratio, that's when they sound consonant together. For example, an octave can be represented in the ratio 1-2, because when you take the frequency of a note such as C and double it, you get C an octave higher. When you get to a perfect fifth, which is the most consonant interval in music, the ratio 1-3 can represent a perfect fifth. So if you take the frequency of C and divide it up into 3 equal sections, you get the note G, because the frequency of G is 1.5 times greater than C. Now when I play this C major chord, the reason those notes sound good together is because of the waveforms and how they interact. Not only do they begin and end at common points, but also their waveforms interlock at common points, as you can see up on the graph. Those are the frequencies of the notes I just played. That's the C major chord, and that's why they sound good together. Now we get into the psychology of music. When you listen to music, your brain actually releases a chemical called dopamine. And this biochemical reaction is the same thing that happens when you eat food, or if you do drugs, or if you have sex. And dopamine causes your brain to actually crave more, which can cause even music to be an addiction. Now when you anticipate things in a song, that's when the most addictive part comes. When you are waiting for your favorite part in that song to come up, that's when anticipation occurs, and that's in a totally separate area of your brain and actually the most powerful. They've done some studies on the difference between happy music and sad music and how that activation in your brain and how that affects that. And when it comes to happy music, if you have lyrics, only your auditory regions of your brain are affected. But if you were to take away those lyrics and just have instrumentally happy music, actually there's a lot more activation occurring in your brain. When it comes to sad music, there's actually the opposite effect. With lyrics, sad music causes a lot of brain activation in many different areas. But take away those lyrics and just listen to instrumentally sad music, there's not a lot of brain activity. And so this is just a little tidbit into something that might be more exposed in the future. Right now, science only has the facts, but we're still figuring out why these things happen. Now, when we read Romans 1:20, it says, "For since the creation of the world, God's invisible qualities, his eternal power and divine nature, have been clearly seen, being understood from what has been made, so that people are without excuse." And I just see that everybody is without an excuse to say that there isn't or is a God, because God compiled so many aspects of his creation into one creation, which is music. He included the aspects of art, psychology, physics, anatomy, mathematics, and I just see that not only did God give us the gift of sound, but he also allowed consonants in the sound, and for that to impact us psychologically. And I just see all the complexity behind the science of music, and I see that there must have been a creator. Thank you.
Oh, that was awesome. Oh, no. Earthquake. Okay, it's gone. Now time for questions.
You obviously did a lot of research. What was the one piece of research that really was the most interesting to you?
I'd say between the consonants of harmonies and how they fit together in their waveforms and how they interlock and why certain notes sound good together and certain keys and stuff don't match up. That was the most interesting for me.
Would someone who doesn't really believe in God, like I should go off to UCF, do you think that they would agree with your conclusion?
I think so, because I just don't see how all of this could just appear or evolve or whatever you believe. Just seeing the complexity, like even evolutionists look at the eye and see the complexity of it, and they're just amazed, and sometimes they can't even explain it. I just see the same thing in music, and that there's just so much behind it in the science, and it goes even on beyond the fact that it sounds good, it's enjoyable to listen to. There's a lot going on behind the scenes.
What was the most interesting piece of information or data that you found during your study?
I would say the harmonies and stuff like that, because I've been learning how to harmonize even like with my voice in the past few years, so just learning how that is physically happening in the air was really interesting.
Another earthquake! Earthquakes everywhere! No! Earthquakes!
One song that is not good is the
Okay, we're good.